Today we are starting a new topic, that is parabola. What is definition? See, we have one fixed line, okay, and we have fixed point. One fixed line is there, one fixed point is there, and this fixed point should not lie on the fixed line. All right, and collection of points whose distance to this fixed point and fixed line are equal. Those collection of points we are calling it as parabola. For example, what points I would like to collect? I would like to collect those points, okay, whose distance to this fixed point. Okay, let's say this is pi. Distance to the fixed line, if it is also 5. Okay. So what is specialty of this point A? A's distance to the fixed points is 5. Distance to its fixed line is also 5. Similarly, let me take another point B. Let's say its distance to the fixed point is 6 and distance to fixed line is 6. Similarly, there can be some other point here. Okay, let's say this is 4 units. This is 4 units. So if I collect all such points whose distance to the fixed point and fixed line are same, so the figure I am going to get, that particular figure is called parabola. Yes. See, when we started circles, what did I tell you? You need fixed point and fixed distance. Okay. Suppose I have fixed point C, and I need all points which are at a distance of 5 units from C. Okay. I need all points which are at a distance of 5 units from C. So if I collect all such points, the figure I am getting, that is only circle. Correct. So in case of circle, two important things are there. One is what is the fixed point? Okay, what is the fixed point? What is center of the circle? Another one is what is radius of the circle? What is the fixed distance? Right. Similarly, in case of parabola, two important things are there. One is the fixed line. This fixed line we call it as directrix. Other one is fixed point. Okay, this fixed point we call it as focus. All right. Focus is denoted by the letter S. Okay. Generally, focus is denoted by the letter S. So what is the property of any point on the parabola? This parabola is drawn with the help of one fixed point and fixed line. No? Its distance to fixed point, let's say this is 7 units, then its distance to fixed line should also be 7 units. All right. Suppose I have this is a point on the parabola. That means what? Its distance to focus, that is the fixed point. Let's say this is 8 units. All right. This is 8 units. Then its distance to fixed line, that should also be 8 units. All right. So how do I define parabola now? Parabola is nothing but what? Collection of points. We have to collect points. What is the specialty of these points? That their distance to fixed point and their distance to the fixed line both are same. Okay, so I can define parabola like this. It is nothing but collection of points, locus of a point, equidistant to, you have to collect points which are at equal distances to fixed line, that is directrix, and fixed point, that is focus. Okay. So to draw a parabola, what are the things? What is important to draw a parabola? Fixed line is important. Fixed point is important. Fixed line other name is directrix. Fixed point other name is focus. Okay. One important information here is focus should not lie on directrix. All right. Okay. So that means if I give you directrix and focus, that means you should be able to find the equation of the parabola. Like in case of circle, if I'm giving you center and radius, you're able to find the equation of circle, right? Similarly, here, if I give you directrix and focus, okay, directrix means fixed line, focus means fixed point. If I give you this, you can collect all the points equal, which are at equal distance to them. That means you can find out equation of parabola. Let's see one question. Find equation of parabola whose directrix is 2x plus 3y plus 5 is equal to 0 and focus is at focus at 2 comma minus 1. Okay, so I have given directrix, I have given focus. So now we can easily find equation of the parabola, right? So what is given? 2x plus 3y plus 5 is equal to 0. That is directrix. Focus is 2 comma minus 1. Okay. What I need to collect the points whose distance I need to collect point. I need locus of this point. What is the specialty of this point? This should lie on parabola means its distance to focus should be same as its distance to directrix. So like any locus problem, we solve it by taking the point whose locus we are finding it as, whose locus we are finding as h comma k. Then we write the geometrical condition. What is the condition? SP is equal to PM. What is SP distance? Root of h minus 2 whole square plus k minus of minus 1, k plus 1 whole square is equal to PM. Now what is distance between P and the fixed line directrix? What is this perpendicular distance?
2h plus 3k plus 5 by root 30.
Yes, 2h plus 3k plus 5 divided by root of x quotient square plus y quotient square. That is 2 square plus 3 square. Okay. Now I do squaring on both sides and then I'll replace h comma k with x comma y. That is x minus 2 whole square plus y plus 1 whole square is equal to, when I square, modulus will be removed, replace h comma k with x comma y divided by root 13 whole square is 13. So if I send 13 to other side and manipulate, I'll get 13 into x minus 2 whole square plus y plus 1 whole square is equal to 2x plus 3y plus 5 whole square. Okay. So I can simplify this and write this in the form of ax square plus 2hxy plus by square plus 2gx plus 2fy plus some constant equal to 0. Right? Bring all the terms to one side, arrange like this. So that would be our parabola equation. This is equation of our parabola. Equation of parabola. That means what I just got here is an equation which is satisfied by every point on the parabola. Okay, first let me quickly draw the parabola here like this. Okay. What is the property here of all the points on the parabola? Distance to focus and distance to directrix same. So this is alpha, this is also alpha. This is beta. This is also beta. So all these points on the parabola, okay, they satisfy one equation, right? What is that equation? That is this equation. So if I give you directrix and focus, finding equation of parabola is very, very easy. Okay. You know, when I gave you directrix and focus, no, I kept in mind that focus should not lie on directrix. Is this satisfying directrix equation? Just check. That is focus satisfying equation of the directrix? 2 into 2 minus 3 plus 5. Right. So definitely focus is not satisfying this line equation. That means focus is not lying on directrix. All right. Fine. Next. Okay. Suppose I have 2 points. This is important. If I have 2 points A and B, if I ask you collect all points equidistant to A also, equidistant to A and B, you collect all points whose distance to A and distance to B same, then what would be the locus? equidistant to A and B. If I say this, then what would be the locus? Yes.
So it would be straight line.
Yeah, it is straight line. Which one exactly? Straight line? Okay, what I need is I need to collect points whose distance to A and distance to B is same. So that would be, if I collect such points, that would be perpendicular bisector of line AB, a line segment AB. So this AB line segment is there, no? It's perpendicular bisector. All right. So that means on perpendicular bisector of line segment AB, I think this I am saying for fourth or fifth time this point. That means that it is that important. On perpendicular bisector of AB, if you take any point, distance to A and distance to B both will be same. Right? That is the locus definition of perpendicular bisector. Okay. What if I give you this scenario? Uh, Locus of a point equidistant to two lines. Two points are given, fine. Equidistant to 2 points, locus is perpendicular bisector. Two lines are given, then what will be locus of point equidistant to? Okay, we need collection of points whose distance to line L1 is equal to 0 and L2 is equal to 0 are same. Then what should be done? What I'm saying, from we need that point from P to L1 equal to 0. If we find distance, P to L2 equal to 0, we find distance. Both should be same. So collection of all such points will be what?
Angular bisector.
Yes, angular bisector. Speciality of angular bisector is if you take any point on angular bisector, distance to both the lines will be same. Okay. What this angular bisector also, right? Here also. Okay. Here also, this is also angular bisector. Let's say this is theta, this is theta. So this should be 90 minus theta. This should be 90 minus theta. Right. So two bisectors we are having. Speciality of any point on the bisector is its distance to both the lines will be same. Okay. So if I give 2 points, find points at equal distance to 2 points. Then you will say, okay, the locus is perpendicular bisector. If I give two lines and ask you collect all points equal at equidistant to two lines, then you will say locus is bisector. Okay. If I give 1 point and one line, okay, locus of point equidistant to a line and point. Okay. Point does not lie on the line. Then what would be the locus in this case? Line is there, point is there, point is not lying on the line. I need collection of points. These points distance to this fixed point and fixed lines here. This is what they're asking of. These two are same. And collection of such points will be what?
Parabola.
Parabola. Like this. 2 points are given, equidistant to 2 points means perpendicular bisector. Two lines are given, equidistant to two lines means angular bisector. 1 point, one line is given, equidistant to point and line means parabola. Okay, provided this point, no, this point should not lie on the line. S should not lie on the line. Okay, then that leads us to one more, gives us one more case. Okay, what if locus of point equidistant, locus of point equidistant to a line and a point. To a line and a point. If point lies on the line. If point lies on the line. Then what? Okay. Meaning what they're saying? There is one line like this. On this line, there is one point. Let's say P or S. Let's say. Fixed point is there, fixed line is there. Fixed point is lying on the fixed line. Then we need to collect all points whose distance to S and distance to the line are same. Then what would be the locus here? Okay. What I need, suppose I say P is the point on P is the required point. That means I am saying P to S distance and P2 point distance and P2 line distance. Both should be same. Okay. Can this point P be the required point? Definitely not, because P2 S distance, that is hypotenuse, and P2 the line distance is, so if you see there is a right angle triangle. Okay. P2S is hypotenuse, P2 let's say M. That is the other side of the right angle triangle. So definitely PM is less than PS. Okay. So I want PM is equal to PS. So how should the locus be? Think about it.
So it should be perpendicular.
Very good. Nice. You are right. P, if you take like this, P to S distance. Okay. P you take on this line, on line perpendicular to the fixed line and passing through focus. Sorry, I mean S. If you take P anywhere on this line, P to S distance is same as P to line. No? What is distance between P and this line? 4. Distance between P and S, that is also 4. What I want, distance between P and line and distance between P and S should be same. So yes, point P can be here. Okay. Similarly, if I take point P here, it's now distance between P and S, that is 5. Distance between P and line also will be automatically 5. So if I collect all the points such that P to S distance and P to line distance same, then what is the locus I am getting? Your locus is line perpendicular to given line and passing through the given point. Okay, I think this is just discussion. Okay, but important thing till now we should understand what is the definition of the parabola. I hope that is clear. Okay, next we'll see there is something called eccentricity. Okay, all right. So I have fixed line. No, I'm calling this as directrix. I have fixed point. I'm calling it as focus. Okay. Now, if I take any point in the plane, distance between point to that point to focus is PS. Distance between that point to directrix is PM. This ratio SP by PM is what we are calling it as eccentricity. Okay. SP by PM ratio is what I am calling it. What we are calling it as eccentricity. That means what? They will give you focus. They will give you directrix. Okay. If they say eccentricity is 10, that means what? We have collection of points. Ratio of its distance to focus, that is SP, to that of its distance to directrix, that is 10 they are saying. That means it can be like this, 10, 1, 10 is to 1. Otherwise, it can be something like 20 is to 2, like this. All right. So that is eccentricity. What is eccentricity in case of parabola?
1.
Yes, 1, because in case of parabola, this distance and this distance both are same. SP and PM are same. So in case of parabola, eccentricity is equal to 1. Eccentricity denoted by letter E. All right. So more discussion on eccentricity we will do in the upcoming chapters. That is in ellipse and hyperbola. Right now, this is sufficient. Next, general equation of parabola. You remember general equation of circle we have studied. Okay. Similarly, we are studying general equation of parabola. All right. To find parabola equation, we need two things. One is directrix. Directrix, let me take it as ax plus by. Should I take lx plus m? Anything we can take. I'm taking lx plus my plus n is equal to 0. And focus. Okay, I'm taking it as alpha comma beta. I need directrix and focus. How to say focus will not lie on directrix in maths. A alpha plus b beta plus c is not equal to 0. This is given. So what is equation of the parabola now? Focus is given alpha beta. What is the equation of the parabola? We take it as h comma k, locus of this point, right? We take it as h comma k, finally replace as x comma y. So anyway, directly let me take as x comma y here. Lx plus my plus n is equal to 0. This is SP. So equation of the parabola would be SP is equal to PM. So root of x minus alpha whole square plus y minus beta whole square is equal to modulus of Lx plus my plus n divided by root L square plus n square. Already we have solved one numerical problem based on this. So reaching till here would not be any problem. Okay. Now let's do squaring on both sides. What we get? X minus alpha whole square plus y minus beta whole square is equal to Lx plus my plus n. Mod will get removed when we square divided by L square plus n square. Any parabola equation, definitely any parabola you take, it will be generated with the help of one focus and directrix. So that means every parabola will have one focus, one directrix. Okay. So every parabola will have equation like this. All right, this I am calling it as form 1. So that whenever I refer form 1, you will understand, okay, I am referring to equation of this type. Okay. Only in our class, right? When I say form 1 of parabola, you remember like this one. Okay. All right. So what is form 1? Okay. Our general equation of parabola in form 1 means focus is given, directrix is given. What would be the equation? X minus alpha whole square plus SP square. Okay. Remember like this. SP is equal to PM. Then we will square on both sides. SP square. So you take a point here. SP square means x minus alpha square plus y minus beta square is equal to PM square. Perpendicular distance from point to directrix, you find, then square it. So you get Lx plus my plus n whole square divided by L square plus n square. Okay. See, observe the denominator here. That is directrix x quotient square plus y quotient square. All right. So let's solve one question. Find equation of the parabola whose focus is at x plus y is equal to, whose focus is 2, 1 and directrix is 2x plus 3y y every time to x plus. Let's take x plus y, x plus 2y plus 1 is equal to 0. Yeah, what would be the equation of parabola in this case? Directly, even let's not even draw the diagram. Sp square is equal to pm square. X minus x coordinate of focus square plus y minus y coordinate of focus square is equal to, right side, what is there? Directrix expression whole square divided by directrix x coefficient square direct plus directrix y coefficient square. So that means what is the answer? We are getting x minus 2 whole square plus y minus 1 whole square is equal to x plus 2y plus 1 whole square divided by 5. 5 you can send to other side. And depending on options, we will simplify. All right. So this is clear. Let's do one more example very quickly. Right. Find equation of parabola. Find equation of parabola where directrix is 5x plus 3y minus 1 is equal to 0 and focus is 1 comma 1 minus 2. What would be equation of the parabola? Yes. Jivitesh, what is equation of the parabola?
Minus 1 whole square plus y plus 2 whole square equal to
Okay, x minus x coordinate of focus whole square, y minus y coordinate of focus whole square is equal to
5x.
Yeah,
5x
directrix
plus
expression 3y minus 1 whole square divided by
root 5 square plus 3 square.
no root won't come because we have
Sorry,
squared
1
it.
5 square plus 3 square.
We are writing sp square is equal to
Yes,
pm
sir.
square.
Yes.
So this would be the equation. Okay, so I'm changing the question a little bit. Find focus and directrix of the parabola whose equation is focus and directrix of the parabola whose equation is like this: x plus 1 whole square, oh, x plus 1 whole square plus y minus 2 whole square is equal to 3x plus y 1 comma minus 2, right? Plus 5 whole square divided by 10. Yeah. So what would be the answer to this? What is focus and directrix? Quite easy question. Focus and directrix. Vagdevi?
Focus is minus 1 comma 2.
Very good. Focus means you just equate this to 0 and equate this also to 0, right? When you equate this to 0, you get x coordinate of the focus, and when you equate this to 0, you get y coordinate of the focus. So focus would be minus 1 comma 2. Directrix 3x plus y plus 5 is equal to 0. All right. This is directrix expression square. So one more question. Find lambda if 2x plus 1 whole square plus 2y minus 3 whole square is equal to 4x plus y plus 20 whole square lambda. If the equation represents parabola. If this equation is representing parabola, right, then what would be the lambda value? That is the question. So first you have to convert into form 1. Then we can solve, right? Form 1 is like this. This is directrix expression. In the denominator, we get directrix expression x quotient square, y quotient plus y quotient square. So try to express this in this form, then you can find lambda value. Okay. One more question. Also find focus and directrix. What is focus? Here, focus must be easy only. Navya,
Minus 1 by 2 comma 3 by 2.
minus 1 by 2 comma 3 by 2. What would be directrix?
4x plus 5 plus 20.
Right. All right. Okay. So let me try to express this in the form 1. Okay. So first I have to make x quotient here as 1. Here also I want y quotient as 1, right? So take 2 square common. 2 if I take outside, because square is there, 2 square will come out. X plus half whole square.
Sir, lambda 1.
Lambda value is 1. Okay, we'll check. Y minus 3 by 2 whole square is equal to lambda 4x plus y plus 20 whole square. So this is x plus 1 by 2 whole square. So 4, here also 4. 4 comes common. So into 4 is there. And this 4, I am sending it to other side. So it will become division with 4. Okay. All right. So, but parabola equation with this focus and this direct. So now I understand, right? Focus coordinates minus half comma 3 by 2 and directrix expression will be this. So directrix equation is 4x plus y plus 20 is equal to 0. Okay. So if my directrix is expression is 4x plus y plus 20, so what should come here? Directrix expression square divided by x quotient square plus y quotient. What is y quotient here? 1 plus y quotient square. So it should be 4 square plus 1 square. Here, what is the lambda by 4 is? Actually, it's supposed to be 1 by 17. So compare this to, you'll understand that lambda by 4 is equal to 1 by 7. So what is lambda value? 4 by 7. Did you understand this one? If yes, then we'll proceed to next one. Or you need one more question of this model. Okay, anyway, I'm giving just one additional question. Try this. Find lambda if x minus 3 whole square plus y minus 1 whole square is equal to lambda times 2x plus 3y minus 5 whole square represents parabola equation. So what is it?
1 by 13.
1 by 13.
1 by 13 is right. Okay, fine. I think focus is 3 comma 1. Directrix is 2x plus 3y minus 5 is equal to 0. Then actually here 2 square plus 3 square should be there. Okay. So that means by 13 should be there. 1 by 13 into this should be there. But instead of 1 by 13, I have given lambda. So lambda value must be 1 by 13. All right. So form 1 we have understood thoroughly. So form 1 is all about finding parabola equation if directrix is given and focus is given. Okay, let's explore a little bit more. Equation of any parabola with focus alpha comma beta and directrix Lx plus My plus N is equal to 0 would be in the form of, it would be in which form? That is x minus alpha whole square plus y minus beta whole square is equal to Lx plus My plus N whole square divided by x quotient square plus y quotient. Directrix x quotient square plus y quotient square. Okay. Let's cross multiply. Lx plus My plus N whole square. That's you see it. All right. So this is in form 1, right? What I'm doing, this L square plus M square, I have sent it to other side. All right. Now I multiply everything. I'll get something into x square plus something into y square plus something into xy plus something into x plus something into y plus some constant is equal to 0. All right. Can you directly tell me what is x square quotient? See, here we get x square, correct? So when I expand this here, I'll get x square minus 2 alpha x plus alpha square. So this is multiplied with L square plus M square. So left hand side, x square quotient will be L square plus M square. Right hand side, when you expand this, a plus b plus c whole square formula, you will get L square as x square. When you send this L square x square to other side, it will become minus L square x square. So what is overall x square quotient? From right hand side, you will have L square plus M square. Left hand side, you have L square x square. No, that I am sending to left side. So minus L square. Similarly, can I get y square quotient?
L square plus M square minus M square.
L square plus M square minus M square. Good. What about xy coefficient? Here xy term will not come. Here xy term will not come. So only xy term is here. When you square it, we get 2lmxy, right? Okay. A plus b plus c whole square. How do you get xy term? 2ab, 2lx into my. So this side we get xy term. Xy coefficient is 2lm. So when you send it to other side, it will be minus 2lm. Okay. Plus something into x, plus something into y, plus something equal to 0. Something. So we don't care what is x quotient, y quotient, and some constant term. What I want to show here is observe second degree terms. What are second degree terms? X square term, y square term, xy term. These are second degree terms, right? Let's look at their coefficients. Something interesting is happening. So here L square is getting cancelled. So I get m square x square plus L square y square minus 2lm xy plus something into x plus something into y plus something is equal to 0. All right. What did you notice here? The second degree terms.
M minus L.
Very good, very good. This is mx whole square and ly whole square minus 2 into mx into ly, right? Plus something into x plus something into y plus something is equal to 0. That means this is going to be a square plus b square minus 2ab. It is mx minus ly whole square. Okay. That means these second degree terms are there, no? The second degree terms form perfect square. Okay, let's see from the beginning what has happened. Parabola is having focus as alpha comma beta, directrix as lx plus my plus n is equal to 0. So its equation is like this. So we manipulated it by multiplying with L square plus M square on both sides. Finally, we get a result. Okay, that every parabola equation will be in this form. And the second degree terms are there. What are they doing? They are forming a perfect square. All right. So based on this, I can just quickly frame one question. All right. One question can be asked like this. If x square plus 4xy plus lambda y square plus 3x plus 4y plus mu is equal to 0 represents parabola equation. Then find lambda. Then find lambda. I'm saying this is representing parabola equation. Then lambda value should be 1. Second degree terms must form perfect square. That is the concept.
Lambda is -2.
Lambda is what was there?
-2.
-2? No, no, no. Check again. When does it be perfect square? Actually, it is like this, no? A square plus 2a. What is b now? To get 4xy, I should write 2y here. So that means here what should come? 2y whole square should come. All right. Now tell me what is lambda? Lambda is y square quotient. Y square quotient here would be 4. So lambda value is 4. All right. Are you understanding this?
Yes, sir.
All right. Nice. Next. One question we will see. One more. No, one more we will see. That is. Let's. Okay. When does ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represent parabola equation? Okay. When does it represent circle equation? In circle chapter we have studied.
A equals to b and x y and 2h equals to 0.
X square quotient, y square quotient should be 1. I mean, a value should be equal to b, right? X square quotient, y square quotient equal. Yes. Not necessarily 1, it should be equal. And xy term should not be there. That means it should be 0. So when does this equation represent parabola equation? All right. So if you remember, just now we have got equation like this: -2 ln xy plus n square y square plus something into x plus something into y plus something, right? Every parabola equation will be like this, where lmn lx plus my plus n is equal to 0 is equation of directrix. Okay. Now I'm saying the second degree term should form perfect square. No? Okay. When does second degree term form perfect square? Two ways of thinking. First way, equate x square coefficient. Here m square, here. M square is here. Equate y square coefficient. M square b. Equate xy terms. Xy coefficients. Minus 2 lm is equal to 2h. So minus lm is equal to h. Alright. So now you square it both sides, square on both sides. H square is equal to L square M square, right? So that means H square would be equal to L square, that is N square. Where is L square? I think this is L square, not N square. Just let's check once. Yeah. L square. L square M square. So L square M square. So this is L square. So H square is equal to AB. So any parabola equation would be in this form. When I compare it with the general second degree equation, I notice that I'm getting H square value should be equal to AB. This is one way of thinking. Another way is like this: ax square plus 2hy plus by square. These are second degree terms. I'm saying these second degree terms should form perfect squares. That means this is root ax whole square plus this would be root by whole square. Then here what should come? It should be a perfect square. It should be in form of a square plus 2ab plus b square. So here what should come? Two into root ax into root by should come. Okay. So that means what is xy coefficient here? 2 root a root b. Here what is xy coefficient? That is 2h. So that means h square is equal to what? AB. In this way also we can. Okay. So when is this second degree expression representing parabola equation? First condition, delta should not be equal to 0. Any idea what I mean by delta? What I mean by delta? You remember this? ABC plus 2G, 2FGH minus AF square minus BG square minus CH square. That should not be 0. Because if it is 0, then what happens? If delta is 0, then it will be, we will be able to break it down to two lines. That means we have pair of lines. First condition is delta should not be equal to 0. Second condition, h square should be equal to a. All right. Similarly, in case of circle also, delta not equal to 0 is definitely one condition. In case of circle, x square coefficient, y square coefficient same. Xy coefficient should not be there. On top of that, one more condition is there. That is, we should not be able to break the equation into pair of straight lines. So that is delta not equal to 0. So when is this representing parabola? When delta is not equal to 0. Another one, h square is equal to ab. Okay. Similarly, in case of ellipse, we will study this equation will represent ellipse equation if h square is greater than ab. Oh, sorry, h square is less than ab. It will represent hyperbola if h square is greater than ab. All right. So let's write all the conditions here once. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is general second degree equation. When is it representing pair of straight lines? When delta is equal to 0. What is delta? ABC plus 2FGH minus AF square minus BG square minus EH square. One more way to write this in determinant form is like this. So if I expand the determinant, we get this. All right. When does this represent circle? When does this represent circle? When delta not equal to 0. First of all, we should not be able to break it down into two line equations. X square quotient should be equal to y square quotient. XY quotient should not be there. When does this represent parabola? When does it represent ellipse? When does it represent hyperbola? Okay. It represents parabola when we should not be able to break it down into two line equations and h square equal to AB. Saying h square is equal to AB is same as translating. Okay, this is in maths. In English, we translate this is same as saying second degree terms must form perfect square. Must form perfect square. Okay. Or also same as saying eccentricity 1. For ellipse, we should not be able to break it down. This equation, we should not be able to break it down into two lines, and h square value is less than that. We will derive when I discuss ellipse chapter. Okay, delta not equal to 0 and h square value is greater than 8. This is like saying eccentricity greater than 1. This is like saying eccentricity between 0 to 1. Now, don't worry about ellipse conditions and hyperbola conditions because we are only currently dealing with parabola chapter.